Hello, this is a tutorial on how to run CHIPSPIPE both on your own machine and on a supercomputing cluster. So let's get to it. Let me make this a little bit bigger so you can see. So what I'll cover is the libraries that are required, how to download and install CHIPSPIPE. Then I'll cover how to run the batch scripts on, for example, Compute Canada. Finally, I'll talk about how to run CHIPSPIPE locally on a local machine. And then I'll talk about how do you analyze the data. Okay, so I'll split this up likely into a few different videos. So let's just get to it and we'll see where we get to. Okay, so first of all, what libraries do you need? So what we'll do is we'll navigate to the CHIPSPIPE GitHub repo. So what I will do is I'll open the GitHub a Firefox tab, and I'll go to GitHub. This is my own repo, and right now CHIPSPIPE is only available in the Chime Pulsar repository, but I will make this available to everyone right after this video. So here we go. This is the Chime Pulsar CHIPSPIPE GitHub repo. There's some pretty good documentation on how to run the pipeline here that you can read. Of course, we'll go over all of this in this tutorial right now. You can clone the repo by going here and cloning the SSH link. So this is how to use GitHub and how to use Git, so I won't teach you that here. Now, the libraries you'll need is SIG-PipeRock, you will need Fetch, and you will need Yaw. You'll also need Presto and PS Archive. So I'll let you, installing these programs are sort of essential for a lot of Pulsar processing. So I won't I won't explain how to install them here in this video, but just know that you need to install them at some point. Okay, so the next step is to run, the next thing I want to talk about is to run CHIPSPIPE on filter bank files on a computing cluster like Compute Canada, which is what I will show you. So here we go. Here we have Compute Canada. Let me just zoom in so it's big. And let me clear the screen. You can see that I am in my scratch space on Compute Canada. So on a computing cluster, they normally like you to work in a scratch space. Okay, so let's see what's in the scratch space. So you got all these folders. And I will go into this folder, J2105 plus 6223, because this is the folder for my for this pulsar, for this rat I want to search. So we want to search for single pulses using CHIPSPIPE. And here you can see within this folder I have two filter bank files. Now, depending on where you have downloaded CHIPSPIPE, that's where you need to run the file from. So I've downloaded it into my home directory. I've got a Chime Pulsar automated filter bank. And all I need to do is run check single pulse. I give it a -B flag for batch submission. I give it a -D flag for dispersion measure, and I have to give it a dispersion measure, so this is 50. And then all I need to do is give it the filter bank files it needs, right? So you can specify exactly what filter bank files you want to give it. So like in this case, I will specify 2. The other thing you can do is you can give it wildcards. So for example, I can go start.fill. Or if I have some names I want to match, maybe I want to do Chime star.fill or gbt star.fill, or maybe I have a lot of filter bank files in this folder, and I want to do J2105 star.fill. So this is up to you. For now, let's just submit this. And what it will do is it will say, oh, okay, there's this file has not been run as far as CHIPSPIPE can tell. So we'll run it, and it will submit a two-part pipeline. The first part is Presto based, and it's a single pulse search plus some machine learning at the end that will grab all the likely candidates by using this clustering algorithm. And then the second part, it will run fetch, which is a machine-based learning, a neural network, deep learning pulse candidate grader. So let's check what jobs are running. So on Compute Canada, it's SQ, and then I'll check which jobs are running under my personal username. So you can see that I have, so ignore the first one. This is a job that I was running earlier today. But you can see I just submitted 4 jobs. 2 for the original part of the pipeline, the first part of the pipeline, which is Presto based, and 2 for the second part of the pipeline, which is fetch. Okay, so the fetch job is dependent on the completion of the first one. So in that case, you don't need to do anything. It should just run the Presto based part of the pipeline, and then automatically, once that has finished, start running the fetch part of the pipeline. What I will do is I will just cancel that because I have actually already run these files. So I'll just show you the results. So let me cancel that. Sometimes Compute Canada could be slow. Okay, so now that's done. Should be cancelling now, so we'll let it cancel. And what we'll go into this folder where I have already run the CHIPSPIPE on the files. Okay, so in this folder you will see that there are two filter bank files, and there's 2 folders within it. These folders include all the diagnostic plots and everything that you will want to see if there's any, to see if CHIPSPIPE has failed in any way. So let's have a look inside this folder. So we'll ls it. And in here you can see that there is a single pulse.ps file. This is, something you can open using a document viewer, sorry. There is the RFI find.ps file. Again, you can open this using a document viewer. There's also some log files. One especially important one is this automated filter bank, blah 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 .log. So this is all the outputs of CHIPSPIPE that's logged in here. There are also these nsub folders. This is the candidates that has been pulled out of the single pulse search and it's been plotted. But this does not, within these files, so let's go have a look at these files. Within this folder, when this loads, there will be a lot of .pngs. Each one is a candidate. Now, just because it's a candidate does not mean that fetch has graded it to be astrophysical. You shouldn't be looking inside these nsub folders for your astrophysical pulses. This is just to show you that you need to make sure that the candidates were actually created. There should be another file inside these nsub folders that says result_a.csv. This is your fetch grade. Okay, so let me clear that. Let's see what happens if I try to run CHIPSPIPE again. So I was going to do an ls, but Compute Canada is being very slow. So let's just cancel that ls. So let's try and run CHIPSPIPE again. Okay. -b, -d, and let's say it's 50, the DM is 50, and then I'll just run it on all filter bank files. Oh look, it doesn't run. It doesn't send any jobs. That's because CHIPSPIPE knows that it's actually finished all its processing. And you can tell by going to this file here called completed.csv. Every time you run the check single pulse, it will add to this file to say, okay, this is finished, nothing to see here. This is finished, nothing to see here. So we can remove this completed .csv file, and then we'll run this again, right? And then so we can, let's cat this completed.csv file again. It says, well, these two filter bank files have been finished, and there's nothing to see here. Now, what you do after your jobs is finished running is, what you do after all your filter bank jobs is finished running is you run the last script that you'll need, which is get bright burst, and this requires a -i flag, and this is the -i flag tells it which base directory do you search in to grab all of the pulses that Fetch has created as astrophysical. So I'm usually inside the directory of all the filter bank files and of all the folders, so I just give it the base directory here. So it's get Bryce pulse -i, and then I give it dot for the directory I'm in right now. And you'll see it says I can't remove these files because it doesn't exist, and then you'll see a whole bunch of things here. And so what it does is it's now created some more folders called positive burst. So within these positive burst folders, let's have a look at positive burst _1. There are some now more PNGs files. These are the ones that Fetch has said, these are real. These are real pulses from whatever pulsar you're looking at, and you should look at them by eye. If you look at all of the positive bursts, every positive burst folder shows you a different sort of parameter space that Fetch has been grading. So there'll be different, positively graded burst candidates in every one of the positive bursts. So you can see here you have some in this one, some in this one, some in that one. I'll explain what they each mean once we get to the last topic. Finally, there's a positive burst.csv file, and this is just the CSV file of what's in those folders. The 1.0 at the very end just means that it's been graded as a 1.0 or astrophysical. Okay, so that's all for the first part, so I'm going to pause that now.